luckily, the good news is that today's lab is fairly repetitive. Well, maybe that's not good news, but when you watch it done once here, you're going to do the same thing like 3 or 4 times. I think it's 5 times. So, so although we can't get ArcGIS working on the coast right now, at least you'll see it, and if you get it, you'll be able to do it multiple times. You're just going to change. You're basically just going to change the input parameters on the interpolation. So, and then also, I guess, you know, if they don't get ArcGIS working down there in a timely manner, then we'll have to make some considerations for when the assignments due. But hopefully they will. I mean, David Holt said, "Yeah, I got your message." That's all he said. So what we're going to do is get the data here and the lab. And you don't really need the reading right now, but I'll show you the second to last slide in the lecture. Right here, this one is the table you're going to try to recreate, the references in the lab. Okay? So you're going to try to recreate a table similar to this, where you have minimum, maximum, well, you'll have a different title. Let me bring up the actual. So leave that open. And open this up. So what you're going to do is you're going to use the, oops, put the wrong number here, sorry. That should be 417. Okay. All right, so you're going to go to the course webpage, Blackboard, get the data, and I actually have a ArcMap file for you to open. We'll open that in a minute. And it's going to have all of the data for the reading. It's going to have some soil pollution data, and we're going to together take the soil pollution data and turn it into vector data, because right now it's just a tabular form. Okay, and then what you're going to do individually is you're going to do this part where we're going to create a chart similar to that table that I just showed you. Okay, it's going to have 4 columns: minimum value, maximum value, and percent area less than X. You're going to choose an X. Whatever X you choose, you can make it whatever you want, but just make it interesting. And then you're also going to say, what's the average absolute distance from your IDW? Okay, so we'll create the IDW one together. All right. So in your table, they have a lot of comparisons that they're making. So they have, 4 different types of trend surfaces, regression on distance, they have decent polygons, they have 3 different inverse distance equations, they have a thin plated spline, they have lots of ones. You're just going to have 5 different example interpolations. So you have one IDW, and that IDW is the one you're going to compare the rest of them to. So this one will have a mean absolute distance of 0 from IDW. So that'll be useful. You're going to do 1 spline, and you get to choose the parameters that you input. And you're going to do 2 Kriegings and 1 other. The other could be another IDW with different input parameters. Okay, your IDW is just going to be the default input parameters. If you chose a different size or a number of points to use, you could do that. All right, then you're just going to turn in that table, make up a small report, and answer a few questions, and you'll be done. Okay, so let's look at the data first, because maybe it'll make more sense when we look at the data that we're actually dealing with. So I'll open up ArcMap. Huh. So ArcMap doesn't even work on my computer. Funny. All right. All right, so somebody on the server down there needs to do basically the equivalent of this. Whatever server you're using for ArcGIS. I call it server. It's really just a license manager, wherever that license manager lives. I can't see the higher education. You don't need to do this part. Leave it on my computer, it times out. I thought I'd used it earlier today, but didn't. So now it's running the authorization, it's checking with ESRI that we still have a valid license, and it's going to return a message that says you're all good. A little bit lightheaded right now. All right. So now ArcGIS will work, and we want to open up the file, the data that's in the data. So first, did I even download the data yet? I don't think I did. So go to Blackboard and download the data. It's called interp.zip, and then just copy the folder interp. Copy that into a directory. I'm just going to copy it into C, courses, VG. I'm just going to paste it in there. Come out of cost drops. We got one more. We got one more. All right. What is that? Oh. There we go. That might be good. You can just eat it like that? Wow. My daughters would probably love that. All right. So we'll open it up. ArcGIS here. Whew. And what comes up, instead of like opening up a blank, I already have a map document set up for y'all. And what it has is, it has a flood mask. These are areas that get flooded every 1 year, every 10 years, and every 100 years, okay? But I use that to derive this one that's just called land mask. Okay, this is the land. The reason that I'm using this to derive a surface called land mask, or yeah, land mask 2 is what I call it. This surface, you'll need this surface because when it does the interpolation and you find the minimum value, you don't want to find the minimum value beyond this area. In other words, if it interpolates out here, it's really extrapolation, and we don't want it. We don't care about that value. Okay? So you'll see what I do with it in a minute. But we're using this to determine where the edge of our study area is. Okay. All right. So what we need to do is get that. Oops, I had this other window open. Let's close that up now. If you look at the interpolation directory, we have this thing called soil pollution.dbf. Okay, we need to add that data in there. So hit add data, and then go to that directory called and get soil pollution.dbf. DBF is a file extension. It stands for dbase file. And a dbase file is one format that's readily read by ArcGIS. DBase files can also be read by Excel. They're able to open in Excel. So this is a table that represents eastings and northings. Are people familiar with what I mean by eastings and northings? What can I use these fields, eastings and northings, for? Or maybe a better question is there anything in this table that looks like coordinates? Yeah. So I asked it in the wrong order, so then it was kind of more obvious. So eastings and northings are different words for X and Y. Which one would be X? Yeah, easting, and the northing would be Y. Okay. This is actually fairly common system to use. Technically, the universal transverse Mercator system was set up to use eastings and northings, but most of the time on computers we just call them X and Y. Okay, so these are going to be our X and our Y coordinates, and the coordinate system of our data, although it says unknown units, is in the exact same coordinate system. It's a universal transverse, it's a UTM coordinate system. Right? So this is the part in the lab at the beginning where I say, too late, gotta go around. All right. So up here when I say our DBF file, we can import it as an XY event theme. We'll do this in class. We're going to do that right now. So if I go to File and say Add Data, Add XY Data, I called it an event theme. It used to be called an event theme. We'll take another hit. All right. It used to be called Add Event Theme, but they just call it Add XY Data. Remember that event is kind of, it goes back to that statistical terms we talked about before. So we add XY data. We can change the X field to the easting and the Y field to the northing. And we could assign a coordinate system at this point, but there's really no reason to, unless we're going to use this with some other data, which we're not. So we'll just hit OK. At this point, we have a data set that represents, that looks like it's the same data. I mean, that is the same data. Do you have a question, Mike? All right. So if you do get a failed to draw thing, it's probably because it didn't read your data right. Did you please take it right? Sometimes just when I stand behind somebody's computer, it starts working. All right. So there are 2 points here that are outside the study area, but they can still be used in the interpolation to figure out like what the value is right here. Look at this table. In addition to zinc, there's a number of other elements that were sampled. So we got cadmium, mercury, lead, zinc, percent organic matter, and that's really all of them. Okay, so there's all of these. Now when I say in the lab here, Do I say this? I thought I did. Okay. The objective essentially is to select a soil pollution attribute, anything but zinc, because that's the one that they did in the book. So you can select cadmium, mercury, lead. Actually, I don't even care if you select percent organic matter, although it's technically not a pollutant. You can select any of these because what we're trying to do is make a surface. You can select either of these three or that one. And we're going to do interpolation. So we're gonna do an IDW interpolation first. Okay. And then we're going to show what you have to do to kind of clean up the data once you create it. So this is the data set. And we're going to first go up to customize extensions and make sure that you have one called spatial analyst turned on. So you have it turned on? Yeah. Oh, that'd be great.
Yeah. So he just didn't want to. He got Dr. Holmes' email. He didn't want to get a rough class, so I told him he's stuck right in front of everybody.
Yeah, I mean, that sounds good. What I can do is, it's fine with him coming in right now. I'll get to a real good stopping point in about 5 minutes after I just show this one, just for the video. And then what we can do is he can continue, doing it. And then I'll be around if you all have any questions, or I can re-demonstrate something if you want to. So yeah, just carry on. He can be there. All right. So make sure that you have that turned on, because if you don't have that extension turned on, it won't work. Typically, it's turned on already if somebody else has used it. Okay, so the next step is to open up our toolbox and go down to Spatial Analyst Tools and go to Interpolation. Now you'll notice that inside of Interpolation, there are a lot of the operations that we talked about today. There's IDW, there's kriging, there's natural neighbor, which is another method. This just creates a raster version of Thiessen polygons. There's spline, which we talked about today. Spline with barriers is just a version of spline. We don't have what do you call it? Create 10 there. Create 10 is actually in 3D Analyst Tools and under triangulated surface, and no, it's not there. Three features. Yeah, where's Create 10? Yeah. No, that's not what we want. Anyway, we're not going to demonstrate that right now. I'll come back to that. So under interpolation, we want to do IDW first. IDW is right here. And we want to choose the default values. So we'll drag our soil pollution events into the input point features. And then for the Z value field, choose one of the fields that you want. I'll just choose cadmium for now, it's the first one. But you can choose any of them. Then at this point, we need to choose an output raster. I'm fine with just using that for now. Just take a note of where it's saving that. The output cell size is the cell size that it will create. I'm fine if you choose the default here, but I think that it just makes it more elegant to choose a size that's more explainable in whole units. So one of the things that I'm going to do here is to make it the same as my mask. So the mask that I created earlier, if I choose, if I hit this little button and I choose the land mask, it will force it to be the same cell size as that one. Okay, leave all the rest of the defaults the same. So it's going to choose a power of 2. It's going to choose the 12 closest points. Finally, what I want you to do is to hit environments. Now under environments, if you go to raster analysis, you'll find another way to choose cell size here. We can choose, let's choose landmass 2, and then choose mask. And for mask, choose landmass 2 again. What this will do is it'll force the interpolation to only happen where there's a valid cell. And then this is kind of optional, but one of the things that I like to do, and it's good to pass along knowledge that actually works, is if you go under processing extent and you go to snap raster and you also choose mask 2, what that does is it makes the raster cell size in every data set be exactly the same. I'm sorry, not just the cell size, but the extent, so that the raster cells are exactly underneath one each other for every data set. It snaps that raster to another raster. So that's something that I always tell people in the spatial analysis class, but since we're not going to use too much raster data on beyond this class, I'll share that with you. So snap raster makes it so that the cells are the exact same shape and in the exact same place. So I changed, I'm going to go ahead and change this too. So I changed extent, snap raster, I changed cell size and mask. I changed all 4 of those, and I said, for each one, I said same as layer landmass 2, or landmass 2. So then I hit OK, and then finally I hit OK again. And when this runs through, I'll have an IDW layer, there it is, and it will be restricted to the land mask. And if I zoom down in really, really small, and I toggle the IDW on and off, the cell size is exactly, the cells are exactly the same. It's hard to see them this close, but the cells are exactly the same size. Okay, so I've created my IDW data set. That's the primary data set for this lab. Okay, so how do I find the minimum and the maximum value? Anybody know that from previous experience in another GIS class? One way is to go to properties and hit source and go down and look at the minimum and the maximum value. They're right there. The min, the max, and the mean. Do I ask you to do mean or just min max? Minimum, maximum, that's it. Okay. So minimum, maximum, you can get that way. And that's a reliable way to get the minimum and the maximum. Now, pay close attention. See, what does that e to the negative 0.005 mean? Yeah, so it's basically what? I round it off to the nearest whole number. What would it be? It'd be 0 point with 5 zeros behind it, 0, 0, 0, 0. So what's to the nearest whole number, what would that be? Yeah, is that what you said? I can't hear very well. Okay, so it'd be 0. Somebody on the coast probably said it too. Oh. Too much at the same time. All right. So that's that. All right. So finally, how do you calculate these things? Percent area greater than or less than X. The reason why I'm asking you to choose X is because if you choose cadmium, you're going to have a different range than if you choose mercury or whatever. So I want you to choose a value that's somewhere in the middle here. It might be good to just choose the mean. Okay. So here's the the mean is 2.4. So I might choose 3 or something. So I want the percentage of area that is less than X, and the mean absolute difference from IDW. We can't do that yet. Okay. Well, the mean absolute is going to be this. All right. So is ArcGIS working on any computers down there yet? No. Okay. Do you want me to stop, or and you can go get them, or just continue for now? Okay. All right. So we did IDW. So let's start creating our little chart here. So what we want is a chart that looks like this. So it says IDW, and then I might even say IDW 212, just to let everybody know that it's power of 2, use the 12 closest. And then I have the minimum and the maximum, and I'll let you round off because that's a really, really small number. And I'll find the maximum, which was what, 18 something. Copy. I'm still going to round that to 3 decimal places, like that. Okay. So there's the min, the max, and then the other values that I wanted you to report were percent area less than X. So I said maybe let's do 3. Area less than 3. So what I'm saying is, for the rest of your studies, use 3. Don't change that anymore. You just come up with a number. And then the final one is difference from IDW. I'll just say IDW diff. Okay. All right. And right now it's a 0. Okay. So how do we calculate the area that's less than 3? How much, for those, you took 217, right? Did you do any work with raster data sets at all? Not really? No, not really. Okay, okay. All right, so I'll just show this to you. Okay, so a raster data set is basically just a bunch of numbers, right? And so all we want to do is ask, is the number in your cell, is it bigger than 3 or smaller than 3? Does that make sense? That's the question that we want to ask. Okay. So how do we do that? Well, there's a tool in ArcGIS under the Spatial Analyst tools called, let's see, which one would be the best? Yeah, there's a tool called Map Algebra, Raster Calculator. Okay, so inside the Raster Calculator, we can say, okay, this is the output, the IDW SHP1. We can take that one and we can say greater than 3. So now what it's going to do is it's going to go to each cell in the raster and it's going to evaluate this expression. It's supposed to be less than or greater than? I think it's supposed to be less than. Yeah, okay. So right, less than. So is the value in each cell less than 3? It's going to evaluate that expression and it's going to put the answer in the cell. Okay? Now, it's going to put the answer as a 1 or a 0 because it's a computer. It doesn't talk in words. So it's going to put the answer as a 1 or a 0. And so now we can run this guy. And it's going to run, and it's going to create a new data set. I'm not sure where I saved it, but I've got a 1 or a 0. So what do the 1s represent? Probably, that you would guess. That they're less than 3. 1s represent if you were to say it in a true or false expression, the ones represent true. So everywhere where it's blue, we have a true, and everywhere where it's not blue or 0, it's false. So the blue area divided by the black area, or sorry, no, the blue area divided by the total is what will give us the answer, the percent that is under 3. Okay? Yeah. Okay. So I'll help you out right there. But this is the number right here. So this is the number that is 1. 1 is the number that's true. If you add these two together, you'll get the overall. So 22032 divided by the sum of 22032 plus 7962. This should all be landmass too.
Yeah.
Get C. Okay, so it's having a problem. I think it's having a problem saving at that location. Let me turn off landmass here. What happened to landmass 2? That's okay. Last layer. Yes, because it's running on there. Yeah. Well, yeah, just hit something there. Like type something. Okay. Yeah. I am still recording. I think. Just a second. I'm answering a question.
Yay, okay.
Okay, so I'm almost positive that the spaces, it's freaking out for some reason. Because I chose an area with no spaces. Let's try something else. So if I call this dot. Okay, so that's saved in your other location. Okay, so all right. So I'm still recording, I hope. And I did have a question, and we got it answered. Let me make sure I'm recording still. Yep, still recording. Okay. So somebody's wasn't running. And the problem is that now that we're dealing in the raster world, ArcGIS by default uses some pretty old code to run these things, unless you specify that you want to save it in a different format. So if you tell it, basically for raster, the default format, if you don't give it an extension, is called an ArcGIS grid, and it's a really old format, and it doesn't accept any spaces anywhere in the path. It'll freak out and die. However, if you specify a extension for your raster, like .tif, which is stands for what? A TIFF, which is an image format. .img would probably work. That's another image format that you're probably actually familiar with if you did stuff in Envy. So that'll work. You could save it into a geodatabase, and probably spaces would be fine. But by default, if you don't save it in a geodatabase, you just save it in a folder, it won't work. Okay, so here is the answer to the third question. So I'll go back over to here. Did you do cadmium? Okay. Well, I mean, everybody's going to get slightly different answers. It's more that you'll see that there's differences in the interpolation. So it's really not important that like I won't grade for different values is what I'm trying to say. So this is going to equal this divided by this plus this. Okay, so 75% of the area, or 73% of the area is less than 3. That makes sense? So 73% of the area, 73 if we're going to go down to 2 decimal places. And all I did was run that analysis. All right, so let's go back here for a second. So okay, hand in. So what I want is for you to hand in the email as an email attachment. I don't send the MXD file, just a Word file of your report. So you could take each of these images like this, okay, and you can turn off the soil pollution events if you want. You could anybody know how to just take a screenshot? There's a few ways. You can use the snipping tool to just copy like that and paste it into Word. Or you can go, ArcGIS allows you to go File, Export Map, and it'll actually export this view to, let's say, a JPEG, and I'll call it interp1.jpg. Okay, so now if I go into, I don't even know where I saved it. Export map. Let's save it somewhere else. I'm just going to put this right in the root of C, save, yes. I'll put it somewhere else. That's where I put it. There it is right there. So I exported an image out of ArcGIS. That'll be a little bit higher resolution. At least you can control the resolution anyway. So that's one method. Okay. All right. So the final thing here is to do a different interpolation method. So then you have to do IDW, 2 krigings, 1 spline, and one other one that you choose. So let's do another one. Anybody care which one we do? We already did IDW. Do one of the Kriegings? Okay. So let's go to Spatial Analysis Tools, Interpolation, choose Krieging, and use the same soil pollution events. Make sure that you choose the same z-value field. Once you lock onto a z-value field, you have to keep choosing the same one. Okay? All right. Then we can leave this the same. Then here we're going to choose which Krieging method that we're going to use. We'll just go with ordinary. You can choose one ordinary and one universal. We'll talk about those differences more next week. You could go into the advanced parameters. But if you don't do the advanced parameters, it'll calculate these things, it'll optimize these things for you, okay? The lag size and all that. So that's usually what people do, unless they have a reason to force the semi-variogram to use certain values, all right? So, you just leave all those defaults there and go again under environments, and choose the processing extent to be landmass 2, snap raster to be landmass 2, and then raster analysis cell size to be landmass 2, and then mask to be landmass 2. So all 4 of those change. You hit OK, and at that point you'll get, sorry, OK twice. At this point you'll get, yeah, same exact one. Yep.
So the processing extent does change the same as layer.
Landmass 2. Processing extent, snap raster, cell size, and mask.
So there's 4 things.
Yep, there's 4 things. Cell size can also be set on a lot of the individual windows, so you can set it in either place, but I just like to make sure I set it in both places. All right, now does this look different than the IDW? Yeah, it does. It's a different interpolation. See how different it is? It's significantly different. All right. Okay, so the final question here, we've got to do the difference from IDW. Okay. Did it work now? Or no? How's it going on the coast for ArcGIS? Okay, cool. All right, so this is the final thing, the last thing that you need to do. We need to figure out what the difference is between Krieging and IDW between each one, okay? IDW's difference between itself is 0. So how do we figure out that difference? Well, we do it the same way we did to find the area less than whatever. We use the raster calculator, only this time we're going to say the difference from IDW. So we take the Krieging one and we subtract the IDW one, okay? Now I said the absolute difference, so you need to just, in parentheses here, put ABS, but lowercase. You can actually select it right there. It's the same, see under math. I could have gone like this, abs, and then selected Krieging minus IDW. The reason that I'm having you calculate the absolute difference is that sometimes it might be up, but sometimes it might be down. We don't like there. You just want to know what the absolute. Okay, so you select those 2, and actually the order of these 2 doesn't matter at this point since we're looking at the absolute difference. And we hit OK. And so what we'll get is a map that shows us where the largest differences are. So the largest differences are right here, right here. Okay, those are the areas where we have the largest differences. And to get the mean difference, all we have to do is right-click on this guy and say properties and go to source and look at the mean. The mean is right there. So copy that number over. Is that the mean? Yep. Copy that number over to here and say Kriging. We did ordinary, right? I'm just going to write Krieg ordinary, and then I haven't found the minimum and the maximum yet, nor the area less than 3. I've only found this one. Okay, but you can repeat the other steps to find the minimum, the maximum, and the area out of 3. Okay. And just to review those really quick. Okay, I could do that easily by going down to Krieging, going to look at properties. Here's the minimum. It's not 0 anymore. Here's the maximum. It's not 18 anymore. But look at that. The difference between, we have the exact same input data, and we have a totally different range on what the minimum and the maximum values were. Okay? All right. What about the area less than 3? Well, we'd have to do that in the raster calculator again, where we'd say Krieging shape less than, is that right, 3? Less than 3? Okay, we hit OK. What's that? The minimum was 0? Okay, I must have messed up. Let me look here, make sure. No, it's right here. Yeah, that's fine. Okay, then so we look at this guy, and we get those 2 numbers. Copy this down. So those are my numbers. So those are pretty similar, actually. So of all the numbers, this one's the most similar. Okay. So you're just going to do that at least 3 more times with one other Krieging, a spline, and one other one. I think the most interesting would be to either do another spline, so you'll have 2 splines, or do another IDW, so you have 2 IDWs to compare. And when I did another IDW, I would change one of these 2 parameters significantly. So I either make 12 go down to 3, or 2 go up to 4, something like that, or both. And you can see how that changed the overall values. All right. You don't have to give it to me in an Excel table, but sometimes it's easy to organize things that way. All right. If there's anything that you want me to redo, let me know. If you want me to answer questions, let me know. You got a question, Michael?
Yeah, it's just because of the venting thing. As long as the rest of it's still working. Does it work to create the? Well, there's no attribute table. So although we didn't cover rasters in this course very well, there's no attribute tables for a continuous raster. So a raster that has more than 32 unique values, there's no attribute table for it. So like if you right click, you try to get the attribute table from that, you won't get it. Here there's only 2 unique values, so that there's a raster attribute table sent to you. So you have to do that, the true false, to get it to go to 0 and 1 to get a raster attribute table. Does that make sense? Yeah, like the true false step. This raster has an attribute table. This raster won't, because it has thousands of possible values. This one only has 2 possible values. This one won't have a raster attribute table either. All right?
Is it okay that my minimum is drastically different than theirs?
For which one, the cream or?
Salt.
We'll figure it out. What?
Salt. Yeah, I was looking at raster next.
Where are the trash cans? Right here.
Wait, tucker in. Oh, sure.
Sorry.
So actually, yeah, for this calculation, I thought we were doing these calculations to get the max. But that actually pretty much is like.
Okay, so what it does is for every cell value, now you have the absolute difference. So the result is a map of the absolute difference. What you want is the average absolute difference. So that's why we took that one and right-clicked on it, got properties, and got the average value.
Okay, so okay, so you do have to always from raster.
Right, but we don't need them in the max this time, only the average.
All right, so we could.
Yeah. Wait. So basically, there's a raw interpolation first. For the raw interpolation, you get the min and the maximum from that. Then you have to calculate two derived products. One is just the true false, whether or not it's greater than 3 or less than 3. And then you look at the attribute table for that. Then you have to calculate the average, sorry, not the average, the absolute difference per cell, and then you find the average absolute difference from the properties. And that's everything you have to find out. What can you do? You need to
I love copy
get
and paste.
Word. You don't get Word? As part of the university, can you get a license to Word?
You get file license.
Yeah, I think that just started recently. Well, how do you do it? You go through iTech?
I think you get more than Word. I think it's Office.
Yes, it's Office Suite.
I'm not sure. There was an email about 3 weeks ago and you had some mail out the link.
I know I call it iTech and come install it. Old Windows. If you don't, what your computer came on, right? Thank you. The department has unlimited licenses.
But I also grade up Windows. Yeah, I figured.
Okay, so that's what you want.
Are y'all working it? Are y'all working the program? Pretty much, y'all just follow this, or you know, all the RGI off all of them. And of course, the other tech that was really good last. It's like, just do this, I haven't done it, so we're all. Yeah.
So is it working like to the ArcGIS or no?
No, it's not. It sees the license file when it's put in. It doesn't allow other the students to connect to the license file on the server. So I'm not sure if Ron explained it to me correctly of where to put it. I'm just following the defaults, and it's just like it's there, but nobody else can see it. That's just a strange one.
Well, like up here, so we have one computer that's the license manager, and
Right.
we only have to install the file on that one. We don't have to do anything on the individual machines.
Right. See, that's why I'm on the license server. for ArcGIS. It's just that when before Rob left, he installed it on a path, and he's like, I'm not sure if that was the right path or not. So I didn't leave. So I'm kind of like trying to figure out on the licensed server, the one machine, if it's in the right spot or and pointing correctly. Because he tells me stop the license manager server process, install the new license file, and then start it back up. That should be it.
On every computer or just the server?
Just the server.
Okay.
And I've done that, and none of the students can access ArcGIS once that's done.
No, or before it's done. Good. Okay. Now, I'm wondering, we established this system with a license manager down on the coast and a license manager up here. But I'm wondering if we even need to do that. Is it possible for you all to connect to the license manager up here?
Honestly, I don't know because I'm not sure who configured this machine, and I don't want to get it so over my head and really mess something up. But
Okay.